Hello, geometry class, and welcome to our notes on section 10.3, arcs of a circle. So I'm sure you all know what an arc is. An arc is a piece of a circle. It's like the line segment of a circle. It has a starting point and an ending point, and it contains all of the points on the circle in between those two endpoints. The definition that I want to focus on here is the central angle. The central angle is an angle whose vertex is the center of the circle. And there is a relationship between the central angle and the arc that it intercepts here. So O is the center, AOB is a central angle, the radii OA and OB determine that it is a central angle. So what is that relationship? Well, the measure of an arc is equal to the measure of the central angle that it intercepts. So if I have a central angle of 120 degrees, the arc that it intercepts is also 120 degrees. Now, if you've heard that there are 360 degrees in a circle, you can see why. There are 360 degrees around that center right there, and thus 360 degrees going around the circle there. Okay, so three kinds of arcs that we'll focus on. A minor arc is an arc that has a measure between 0 degrees and 180 degrees. A major arc is an arc that measures between 180 and 360. So if we look back at this diagram here, the black highlighted arc is a minor arc. It's 120 degrees. The rest of the circle would be 360 minus, that would be 240. The rest of the circle is a major arc. So I know what happens between 0 and 180. I know 180 to 360. What do we call it if it's exactly 180 degrees? That's a semicircle. So a short exercise. I have three different arcs, and we're going to label each one. All right, so the first one, the highlighted arc, starts at C, goes all the way around to D. That is a larger than 180 degrees. That is a major arc. From E to F, well, EF is a diameter, so that would mean that this is exactly half the circle. That's a semicircle. And from A to B, that's only a small portion of the circle. That is what we call a minor arc. All right, some notation. So if we're talking about the measure of an arc, we use a little letter M to denote measure, just like we do for an angle. And the measure of arc AB, that's how we write the measure of arc AB. We'll put a little arc on top. That's the measure of arc AB. Not to be confused with just an AB without the M. That is arc AB. That's the shape. Okay, so the measure of arc AB, that's the measure in degrees. Arc AB, that's the shape. Now, the arc AB, if I were to say arc AB, which arc am I talking about? Am I talking about the minor arc or the major arc? So the minor arc, of course, goes from A to B like that. That's the minor arc. The major arc goes all the way around the circle in the other direction. So let's see how well I can trace the circle with my mouse pad. This is much better than I thought it was going to be. All right, that's pretty good. So the green is the minor arc, the blue is the major arc. If I said arc AB, how do we know which one I'm talking about? Well, if you think back to when we were looking at angles, if I gave you an angle like this and said, okay, I have, there's A, there's B, there's C, and I said angle ABC, you guys would instinctively know that I meant this angle ABC and not the reflex angle ABC going in the other direction. And how do you know that? Like, well, I guess it's a little bit of intuition, but that's just the common way of thinking. Angle ABC is the smaller ABC. So if I say arc AB, I do mean the minor arc. All right. So what if you did want to talk about the blue arc, the major arc AB? Well, what you would then do is just pick any other point on that arc. We'll call it C. And we will say we want arc ACB. Arc ACB. Because that says start at A, go through C, and then finish at B. That's the major arc ACB. So this is the major arc. And this is the minor arc. So unless you have a detour on your way from A to B, you can always assume that we're talking about the minor arc. All right, so some examples. Given the measure of arc AB is 20 degrees, find the measure of arc ACB. All right, well, if AB is 20, ACB is the rest of the circle. So to find out the measure of that, we are just going to subtract from 360. So 360 minus 20 is 340 degrees. That is the measure of arc ACB. Okay, how about the measure of angle of XQY is 110. So what's the measure of arc XDY? Okay, they're giving us a central angle here. The central angle is 110, which means the arc is 110. That tells me that the major arc ADY or XDY has to be the rest of the circle, which would be 250 degrees. This section in your textbook has 6 theorems, and if they were like 6 theorems that had nothing to do with each other, that would be a lot, even if we were still in the classroom. But they are all related to each other. Before we get to those 6 theorems, I just want to briefly give you a definition. What does it mean for 2 arcs to be congruent? 2 arcs are congruent if and only if they have the same measure and they are in the same circle or congruent circles. So it's not enough that the measures are the same. If I told you, draw an arc that's 90 degrees, and you draw a small circle, but I drew a big circle, my 90-degree arc is going to be larger than your 90-degree arc. So there's no way that those 2 arcs are going to be the same. That's why they have to either be in the same circle or congruent circles. And remember what it means for 2 circles to be congruent? It means their radii are congruent. So this second part basically means that they have the same length as well. So if you took a tape measure and measured the arc in inches or centimeters, they would have the same length and they would have the same measure. That's what it means for 2 arcs to be congruent. Okay, so as I said, this section has a bunch of theorems. Luckily for us, all 6 of these theorems are related to each other. So Theorem 79 and Theorem 80 are converses, and they say the central angles are congruent if and only if the arcs they intercept are congruent. So if you have the angles, you get the arcs, and if you have the arcs, you get the angles. Theorem 81 and 82 are also converses. They say if you have central angles, then the chords that they intercept are congruent. So if you have the angles, then you have the chords. And 82 says if you have the chords, then you have the angles. So again, they're if and only if statements. 83 and 84, well, we saw a relationship between angles and chords and angles and arcs. So 83 and 84 are the relationships between chords and arcs. If the chords are congruent, then the arcs that they cut off are congruent, and vice versa. There is a nice way to summarize all of this, and that's just by saying congruent chords, if and only if congruent angles, if and only if congruent arcs. Now, how would you actually use this in a proof? Well, let's say you wanted to show one of these were congruent. As long as you have one of the other ones, you're good. So as you're writing, you might say something like, well, if the chords are congruent, then the arcs are congruent. So if you showed that the chords are congruent and you wanted to say the arcs were, you could say, all right, well, we know AB is congruent to CD. And if the chords are congruent, the arcs are congruent. So arc AB is congruent to arc CD. Or since we know the central angles are congruent, we know the chords are congruent also. Just something like that. So you don't need all 3 parts. You can just use the 2 parts that you have in your proof. Okay, let's do some examples of a proof. Here I have circle B. D is the midpoint of arc AC. So we really didn't define what a midpoint of an arc is, but it works just like segments. So if D is the midpoint, then I could say that arc AD and arc CD are congruent to each other. We want to show that BD is an angle bisector, which means we really want to show that these 2 angles are the same. Well, they're central angles. And I know that if the arcs are congruent, the central angles are congruent. And if the central angles are congruent, then BD is a bisector. And we're done. See how that works? Okay, this one's a little bit trickier. Here I have circles P and Q, and we're told that angle P is congruent to angle Q. And these 2 things up here are congruent, AR and RD. we want to show that arc AB is congruent to arc DC. And you might be thinking, wait a minute, if the central angles are congruent, the arcs are congruent. Yeah, but that only works if the circles are congruent or we're in the same circle. We're clearly not in the same circle, so that's why they give us this hint. Show that circle P and circle Q are congruent first. All right, as I mentioned earlier, circles are congruent if and only if their radii are congruent. So we have to show that PA and QD are congruent to each other. Well, okay, how can we do that? I'm going to invoke an oldie but a goodie. Since I know angle P and angle Q are congruent, what kind of triangle is PRQ? It's isosceles. And the isosceles triangle theorem says that if the base angles are congruent, the legs are congruent. So I can get that PR is congruent to QR. And if PR is congruent to QR, the segment subtraction theorem, I could take away RA and RD, and I'm left with my two radii. Now I have my two radii congruent, which means the circles are congruent, which means I can say if the central angles are congruent, the arcs are congruent. All right, one last example. We're going to try to find the measure of each of these arcs. E is the center of the circle, and the first thing we want to find is BC. Well, the measure of BC is equal to the measure of the central angle, and that's a 90-degree angle. So I know that the measure of BC, oh my God, that's horrible, is 90. That's good enough. Okay, next, I want to find the measure of AD. All right, well, BAD is a semicircle, and here's 50 degrees. So what's left for AD? You guessed it, 130. How about the measure of arc ACD? So I start at A, I go through C, and I finish at D. Okay, what would that be? Well, BD here is 180 degrees. Plus the 50 I get from A to B. So I have 50 plus 180. That's 230. Forgive my handwriting. It is worse than it normally is. Okay. How about BAD? I think we already mentioned BAD is a semicircle. So I could say that BAD is 180 degrees. And the last one we want to find is the measure of angle ADC. Well, AD we've done is 130 and DC is 90. So 130 and 90 is 220. So the measure of arc ADC is 220. All right, guys, I hope you took good notes. If you have any questions, please write them down and ask them when we meet in class on Monday. See you then.